Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video. So in this video, I'll go through everything you need to know for next week's final exam. I'll just do it really quickly. So let's start with statistics. So the first thing we need to be able to do is look at a histogram and determine whether or not data is skewed. So histogram always has frequency along the vertical axis. So the higher the bars, the more frequent that score was. So if we look at this first histogram here, we see that the highest frequency scores are closest to the maximum. The scores are actually increasing in frequency as they get larger. So that kind of data is called negatively skewed. If we have the opposite scenario in which the higher frequency scores are closest to the minimum, we say the data is positively skewed. So just be careful with this. It's sort of counterintuitive. You'd probably think that positively skewed would have more high scores, but it's the opposite. It has more low scores. So if the data is neither negatively skewed nor positively skewed, it's symmetrical. And that's easy to tell because the shape of the data, the bars, make up a shape that's symmetrical. So if I drew a line there, that's like a line of symmetry. So there is another way to determine whether or not data is skewed by using the mean and the median. So if the mean is less than the median, we say the data is negatively skewed. Mean greater than the median indicates that it's positively skewed. And if the mean is approximately equal to, that's what that symbol means, mean approximately equal to median implies that it is symmetrical. So just make sure you know how to calculate the mean and the median. So remember, the mean, you add up all the scores, divide by how many there are, and the median is the middle number. So if we have a data set like this, these four numbers here, to find the mean, I would add up all the data and divide by how many there are. So if I add up the four scores, I get 63. I divide by 4 because there are 4 scores. So then 15.75 is the mean. So to find the median, remember the data has to be in order. So in order, it's 11, 12, 16, 24. So remember, if they're an even number of scores, the median is in between the two middle scores. So it would be 12 plus 16 over 2. And halfway between 12 and 16 gives you 14. So in this case, this set of data here, you can see that the mean is more than the median. So we would expect that the data would be positively skewed. All right, let's get on to probability now. So in probability, you basically need to be able to do two things. The first thing, I'm including Venn diagrams and two-way tables together. You can pick which one you prefer. The second thing in probability you need to be able to do is tree diagrams. So let's look at this question. So in a class of 30 students, 18 Spotify, 13 Apple Music, 3 neither. And we're going to use this to calculate some probabilities. Now this question involves two sets. Set of students who have Spotify, the set who have Apple Music. Of course, students can be in one of those sets, both, or neither. So when we have a question involving two sets like this, we can use a Venn diagram or two-way table. Either one we use doesn't really matter. So I'm going to put this information firstly in a Venn diagram. So note 18 plus 13 plus 3 is equal to 34. I've mentioned 34 people in these categories, even though there are only 30 students. So the only way that's possible is if there were 4 students who were included in the Spotify category and the Apple Music category. The only way this is possible is if there were 4 in both categories. However many you've overcounted, that's how many are in both. So now that we have that, let's draw our Venn diagram. So you must draw a rectangle around the Venn diagram. So we have 2 circles, one for each set. So I'm going to call the sets A and S. A for Apple Music, S for Spotify. So I start by putting 4 in both. There were 4 people who had both. So let's look at this circle here, the Apple Music circle. There's already 4 inside that circle, and I need there to be 13. So I need to add another 9 into that circle. I don't put 13 here because then there'd be 17 inside the Apple circle. So similarly, there are already 4 in the Spotify circle. 18 had Spotify, so I need another 14 in this circle. And the 3 that had neither go outside the circle. Note, 9 plus 4 plus 14 plus 3 does equal 30, so I know I've done something right. So let's now put this information in a two-way table. So a two-way table is actually a 4x4 table, but there are two ways. The two ways we can have A or not A, Apple Music or not Apple Music, Spotify, not Spotify. So the four numbers in the Venn diagram, these four numbers here, are actually the four numbers that will go in these four cells. So Venn diagrams and two-way table display the exact same information. So let's look at this cell here. So this is in column A and row S. This is the people in both. So once again, that's 4. So over here we have people that are not A and S, people that have Spotify but not Apple Music, so that will be 14. Similarly, we have 9 here for people who have Apple Music but not Spotify, and the 3 that have neither go there. So the numbers in the two-way table are the same as in the Venn diagram. The two-way table also has rows and columns for totals. So I've got 18 with Spotify, 12 without Spotify, 13 with Apple Music, 17 without. And everything should add to 30 because there were 30 students. So the only reason we have the Venn diagrams or two-way tables is to display the information in a convenient way. Now these questions, probability questions, will be easy. So the first question, the probability they have Spotify and Apple Music, that's really easy. There were 4 people who had both out of 30 in total, so that gives us 4 over 30 or 2 over 15. So note, whenever you're asked for the probability, your answer needs to be a fraction, decimal, or percentage. It needs to be a number between 0 and 1. So let's now do B. So they have Spotify or do not have Apple Music. So or means you include both of them. So we're looking at all the people who have Spotify, all the people who don't have Apple Music, or both. So these people here, these 4, these 14 have Spotify, these 3 don't have Apple Music. These people are included because they have Spotify, and these 3 included because they don't have Apple Music. So there are 21 in total out of 30, and we can simplify that to 7 out of 10. All right, let's now look at tree diagrams. So let's look at this question here. Bag contains 3 Mars bars, 7 crunchies. I'm going to pick 2 chocolates at random, one after the other with replacement. So if I pick a Mars bar the first go, I replace it with another Mars bar, for example. So I'm going to find the probability that both chocolates I pick are the same. So in the previous example, there were 2 different sets. Here, we don't have 2 different sets. Mars bars and crunchies aren't sets, they're objects. So this is a multi-stage event because I'm doing something, performing an experiment, and then performing another experiment. I'm picking a chocolate, then picking a second chocolate. So there are 2 stages to this event, and when you have a multi-stage event, tree diagrams help you list all of the possible outcomes. So let's look. The first stage, I could get either a Mars bar or a crunchie, and the second stage, whatever happened the first go, I can get Mars bar crunchie, Mars bar crunchie. So I want to list the outcomes by following the tree branches. So I have Mars bar, Mars bar, Mars bar crunchie, and so on. So there are 4 outcomes. So you might be tempted to think that each of these has probability of a quarter. It doesn't, because they are not equally likely. You're more likely to get a crunchie. So I need to write the probabilities on the branches. So first go, picking a Mars bar, there's a 3 out of 10 probability and 7 out of 10 for crunchie. Because I replace them, the probabilities will stay the same next go. So I get 3 out of 10 Mars bars, 7 out of 10 crunchies, and so on. So to calculate the probabilities of each of these events, what I do is I multiply the branches. So I want to find the probability both chocolates are the same. So I'm interested in this outcome where they're the same and this outcome. So the probability of getting 2 Mars bars is 3 out of 10 times 3 out of 10, or 9 out of 100. The probability of getting 2 crunchies, 7 over 10 times 7 over 10, which is 49 over 100. So the probability that both chocolates are the same, I can get 2 Mars bars or 2 crunchies. So I add together those probabilities. The probability I get 2 Mars bars or 2 crunchies, I add together their probabilities, and I get 58 over 100, or simplified 29 over 50, 0.58. So use tree diagrams to help you list outcomes from multi-stage events. Let's now turn our attention to index laws. So we're now looking at index laws. So if we have something like a to the power of 3, you probably know it means you times this, a by itself 3 times a times a times a. So this is called index form, something to the power of something. This is called expanded form. So we call a the thing that's being multiplied, the base, and the power, the little number there, is called the index. That's where we get the name index laws. So you have to know all of these index laws. So let's go through them one by one. So index law 1 says if you have something like a to the power of 6 times a to the power of 4, you keep the same base and you add the power. So that's when you're multiplying bases. So when you're dividing bases, if you have something like x to the power of 7 divided by x to the power of 2, you keep the same base and you subtract the powers. So the third rule is called the power to a power rule. That's when you have something like x to the power of 3, which is a power, index form, raised to another power. So here you keep the same base and you multiply together the two powers. So index law 4 says anything non-zero to the power of 0 is 1. So for example, 2 to the power of 0 is 1. 3 to the power of 0 is 1. But 0 to the power of 0 is undefined. So let's say we had something like 2x minus 3 to the power of 0. So if this thing in the brackets is not 0, then that would equal 1. But if 2x minus 3 were to equal 0, we can add 3 to both sides and divide by 2. That would mean x is 3 over 2. So if x was equal to 3 over 2, this would be undefined because it would be 0 to the power of 0. So make sure you understand 0 to the power of 0, undefined. Anything else to the power of 0 is 1. So for index law 5, it's saying that if you take a product, raise it to a power, that's the same as raising the first thing to the power, second thing to the power. So sometimes you'll need to use more than one index law. So if I have something like 2y to the power of 5 to the power of 3, I'm going to use this index law. I'm going to raise 2 to the power of 3, which is 8, and I'm going to raise y to the power of 5 to the power of 3. But to complete this question, I also need to use the second index law. Y to the power of 5 to the power of 3 is just y to the power of 15. So similarly, if I have something like this, 3x squared over y to the power of 4, let's say this is raised to the power of 2. So index law 6 says if you have a fraction to a power, raise the top, the numerator to that power, raise the denominator to that power. So if I raise the numerator to that power, I go 3 to the power of 2 is 9, x squared to the power of 2 is x to the power of 4. So once again, I use the power to a power rule. And then I can raise the bottom to that power. Y to the power of 4 squared, keep the same base, multiply the powers. How easy is that? So the last one says if you have something to a negative power, it basically goes on the bottom of the fraction, but with a positive power. So if you have something like x to the minus 2, you write it as 1 over x squared. If you have something like 7y to the minus 3z to the power of 4, everything with a positive power goes on top, everything with a negative power goes on the bottom, but write it with a positive power. So what about when I'm raising a fraction to a power? So if I have something like this, and I raise it to a negative power, when you're raising a fraction to a negative power, what you do is you can flip the fraction and write it with a positive power. So now we can just use our normal index law. So raising the top to the power of 4, raising the bottom to the power of 4, 3 to the power of 4, x to the power of 5 to the power of 4. Now, because we have a negative power on top, we can move it to the bottom and write it with a positive power. So we're just left with 1 on top, and on the bottom, 81x to the 20, and write the y with a positive power. How easy is that? All right, the final thing we need to do in this topic is go through scientific notation. So scientific notation is taking really large or really small numbers and writing them in a more convenient way. So we write it as something times 10, always 10 to the power of something. So what goes in this box here So what I do is I start at my decimal place and I keep moving it till the number is between 1 and 10. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. If I move the decimal point there, the number becomes 1.728. That number goes in the first box. What goes in this box, the power, is how many times you've moved the decimal spot. So I moved it 9 spots here, so it's 10 to the power of 9. If the number's really large, this number in the power should be positive as it is here. So what about for a really small number? So the process here is the same. I want to write it as something times 10 to the power of something. So what I do is I move the decimal point until I get a number between and including 1 and 10. So if I move it here, the number becomes 3.625. That goes in the first box. So what goes in the power box is how many places I move the decimal point. So I actually moved the decimal spot 4 places. But because this is a really small number, because I moved the decimal point to the right, this number needs to be negative. So it's 3.625 times 10 to the negative 4. All right, let's now move on to similar triangles. So two triangles are said to be similar if one is just an enlargement of the other. So this means they have the same set of angles and the corresponding sides are in proportion. Now we don't need to check every pair of sides and every pair of angles to determine whether or not triangles are similar. We just need to use one of 4 tests. So I'm going to go through the 4 tests. So the first test is S. It means all 3 sides are in proportion. So these 2 triangles are similar by the SSS test because 10.5 over 7 is equal to 7.5 over 5, which is equal to 9 over 6. All of these 3 fractions, 1, 2, 3, are equal to 1.5. So the sides are in proportion. We don't need to check their angles. We know they're similar. So this number 1.5 is what we call the scale factor. It is how many times larger the sides in the larger shape are than they are in the smaller shape. So sides in this triangle are 1.5 times as large as their corresponding sides here. So this shape has consistent scale factor, so it's similar by the SSS test. So the next one is the SAS test. So this is 2 pairs of sides in proportion and an equal pair of angles. So note the angle that's equal has to be the angle between the 2 sides. So we know the sides are in proportion because 10 over 5 is equal to 8 over 4. So there's a consistent scale factor. The scale factor is 2. But that's not enough yet. We also need the angle between them. I know these 2 angles will be equal because they are vertically opposite. So I have 2 pairs of sides, 1, 2 pairs of sides in proportion, and the angle between them is equal. They are similar by the SAS test. So let's look at this triangle here. When you're not given enough information about sides, your only choice for a test is AAA. So this is not true for congruence. AAA is not a congruence test, but it is a similarity test. If 2 triangles have all their pairs of angles equal, they must be similar. It means their sides will also be in proportion. So these both have a common angle. They also have these 2 angles are equal because they're corresponding angles, and we have parallel lines here. So if 2 pairs of angles are equal, then the third pair of angle must be equal as well. Those 2 will be equal. In fact, they're also corresponding. So the last test is the RHS test. You can only use that for right-angled triangles. So please note, just because you have 2 right-angled triangles, it doesn't mean you have to use the RHS test. You could use one of the other tests. So in this one, we have 2 pairs of sides, but not the angle between them. We have 1 pair of sides, 2 pairs of sides. The scale factor is again 2. So we have 2 pairs of sides in the same proportion, and we also have a right angle. But for the RHS test, it can't be any 2 sides. It must be the hypotenuse, the longer side, and another pair of sides. So note the 3 tests in green involve 2 pairs of corresponding sides being in the same proportion, and the blue one, the AAA, doesn't. So that's how you can differentiate those tests. So we also need to be able to explain why two triangles are not similar, which we'll do on the next slide. So let's look at these two triangles. Now, these two triangles are definitely not similar. So why is that? Well, if we look at the triangle on the right-hand side, this one here, its angles would be 50. This one would have to be 50 because it's isosceles. Base angles are equal, and that one would be 80. Whereas in this one, the other two angles would be 70 and 70. So these two triangles do not have the same set of angles and are therefore not similar. So let's look at these two triangles here. Now, people might say they're similar by the SAS test, but we can't use the SAS test because we do have two sides in proportion. 12 over 10 does equal 9.6 over 8. They're both equal to 1.2. We have two pairs of sides in proportion, but it is not the angle in between. So we can't use the SAS test. We can't use any of the other tests either because we don't have enough information about the other sides and angles. So for these two triangles, we can't say they're not similar, we just don't know. There is not enough information to determine whether or not they are similar. So let's look at finding unknown sides in similar triangles. So let's look at these two triangles here. They would be similar by the AAA test because they have a vertically opposite angle. These two angles are alternate and equal because of the parallel lines. And then we also have a third pair of angles equal. So they're equal by the AAA test. So let's say that this side here is 15 and this side here is 10. The scale factor is the larger side in the larger triangle divided by corresponding side in the smaller triangle. That's 1.5. That means that every side in this larger triangle will be 1.5 times its side in the smaller triangle. So we're going to use this to find the value of x and y. So note x here is in the smaller triangle. So what you do is you find its corresponding side in the larger triangle. So that's 9. 9 and x correspond. They're both touching the angle that's an arc and an x. So 9 and x correspond. So because x is in the smaller triangle, we take its corresponding side and divide by the scale factor. So x is equal to 6. Now when finding y, it's in the larger shape. So we take its corresponding side and times by the scale factor. So you times by the scale factor when finding a side in the larger shape and divide by a scale factor when finding a side in the smaller shape. So let's look at these two triangles here. So they are similar by the AAA test. Two pairs of equal angles is enough to use the AAA test. So here, to find the scale factor can be a bit tricky. So the side in the larger triangle is 10. The scale factor is side in the larger triangle divided by side in the smaller triangle. It's actually 2.5. So once you've got that, it's easy to find z. Z's in the larger shape, so you just take its corresponding side and times by the scale factor. So it's harder to find y. So the side in the larger shape, so this side here in the larger triangle is y plus 8. So we know that that is equal to 2.5 times the side in the smaller shape. So now we've got an equation to solve. When you have an pronumeral on both sides, you subtract the one with the lowest coefficient. So we subtract y from both sides to get this. And then what we do to find y, it will just be 8 divided by 1.5, which gives us 5.3 recurring. So that was a bit of a harder one to find. So that's all I'm going to go through for similar triangles. Make sure that you know how to solve problems using similar triangles as well. I'm now going to go through the final topic of quadratics. So the first thing we're going to go through in quadratics is expanding. You can use the FOIL method. So F is first, the thing first in each bracket, then O, the thing on the outside of each brackets, I is the thing inside each brackets, and then L is the thing that occurs last in each bracket. So here there are some like terms we need to collect. So we get x squared plus 6x minus 7. So let me know if you want me to go over the quick ways, because I'm not going to do that in this video. So when you're squaring something, lots of people think that you just square the first and square the second. Please don't do that. There is a middle term. So we can use FOIL. Squaring something means timesing by itself. So the FOIL method. Firsts, outsides, insides, and lasts. So these two form the middle term. It's actually x squared plus 6x plus 9. So for this last one, this is actually the difference of two squares. So you can use FOIL again or the quick way for this. So the quick way is just square the first, square the second, and stick a negative in front of that. That's the same answer you should have got with FOIL. So when we're factorizing, we're actually going the opposite way. So when we factorize, we start with something that doesn't have brackets and end up writing it as something times something. So there are different methods for factorizing depending on whether it's a binomial or trinomial. So a binomial means that it has two terms. So the first method we look at is highest common factor. That's when there's an x in both terms. So if I have something like 3x plus 6x, what you do is you take the highest common factor out the front and divide each term by the highest common factor in the brackets. So 3x squared divided by 3x just leaves x. So then we do the same for the next term. We take 6x and divide by 3x. Or in other words, what do I times by 3x to get 6x? And the answer is positive 2. So if I were to expand this, I would get that. The other method for binomials is difference of two squares. We're just reversing the process we did here. So when you have a perfect square minus a perfect square, what you do is you get your two brackets, square root the first, square root the second, one gets a plus, one gets a minus. So if I were to use FOIL on this, I would get this. So this example here is also difference of two squares. 4x squared is a perfect square, so 2 is 1, and we're minusing them. So we're going to do the same thing. We're going to square root the first, so that's actually 2x, square root the second, which is 1, and then one of them gets a plus, one gets a minus, and we're done. So sometimes with binomials, you need to use both. So if I have something like 3x squared minus 27, the reason I need to use both is that 3 is not a perfect square, 27 is not, but they both have a common factor of 3. So what do I times by 3 to get 3x squared? X squared. What do I times by 3 to get negative 27? Now this thing here is the difference of two squares. So the way I do difference of two squares, square root the first, square root the second, one gets a plus, one gets a minus. So please pause and copy this down if you need, because I'm going to rub out the binomials and show you how to do trinomials. So trinomials are when we have three terms. What you need to do is find two numbers that multiply to the constant term, add to the coefficient of x. So two numbers that multiply to 15 and add to 8 are 3 and 5. So we just put them in the brackets like this. So it gets a little harder when we involve negatives. Now we need to find two numbers that multiply to negative 12 and add to negative 4. Those two numbers are minus 6 and positive 2, and we're done. So we actually need factorizing to solve quadratic equations, which I'll now go through. So we're going to solve each of these quadratic equations using the steps on your screen. So firstly, one side must be equal to 0. That's actually done in all of these ones. So what we're going to need to do is factorize and then use the null factor law. So for the first one, it's difference of two squares. So we factorize it like this. So the null factor law in step 3 says either the first thing equals 0, so if x minus 6 equals 0, x equals 6, or the second thing equals 0, which in this case means x is minus 6. So when you're solving quadratic equations, there are usually two solutions. So in the second one, it's highest common factor. So we factorize it. Now the null factor law says either the first thing is equal to 0 or the second thing is equal to 0, and that would mean x is minus 6. So once again, there are two solutions, x equals 0, x equals minus 6. If you substitute each of them into this equation, it makes it a true statement. So the third one is a trinomial, so we need to find two numbers that multiply to 1 and add to negative 2. So that's negative 1 and negative 1. So in this case, x squared minus 2x plus 1 is a perfect square. So when it's a perfect square, there's only one solution. If the first bracket equals 0, then x equals 1. If the second bracket equals 0, x also equals 1. So I wanted to go through something like this as well. So let's say we had an equation like this. It might look harder, but it's easier because step one's done, one side equals 0. Step two, it's already factorized. We're not going to go and expand it because it's factorized, and that's what we want. So the null factor law says either the first thing equals 0. So to solve 3x plus 2 equals 0, you just subtract 2 from both sides and divide by 3. That's one solution. And the second solution, if the second bracket equals 0, we have 2x minus 5 equals 0, add 5 to both sides, and divide by 2. So once again, we get two solutions. But I just wanted to point out, if it's already factorized like this, just go straight to step 3 and use the null factor law. So let's do just a couple of challenge questions. So let's look at these two questions here. So starting at the top, sum of the squares of two consecutive numbers is 113. What are the two numbers? So what I'm going to do is I'm going to let x equal the smaller of these numbers. So consecutive means one after the other. So if x is the smaller number, x plus 1 is the larger number. We only want to use one letter, one pronumeral. So now we're going to write this worded information as an equation. So the square of the smaller number is x squared. Like the square of 4 is 16. The square of 13 is 13 squared, 169. Square of the smaller number plus square of the larger number is equal to 113. So we're going to expand the brackets. And then we're going to collect like terms. So obviously x squared plus x squared is 2x squared. Now we have one side equal to 113. I said on the previous slide, you need to have one side equal to 0. So to do that here, I'm just going to subtract 113 from both sides. Then I get 2x squared plus 2x minus 112 is equal to 0. So now all of these terms have a common factor. So I'm going to take out a common factor of 2. So what do I times by 2 to get minus 112? Of course, that's minus 56. So if I solve this equation here, I can ignore the 2. I get x squared plus x minus 56 is equal to 0. So the two numbers that multiply to negative 56 and add to 1, x plus 8, x minus 7. So that means x is equal to 8. That's if the first, negative 8 if the first bracket's equal to 0, or x is equal to 7. So the two numbers are, if x is minus 8, x plus 1 is minus 7, or 7 and 8. So either of those, their squares add to 113. So let's look at the final question here. The quadratic equation x squared plus kx plus 100 equals 0 has only one solution. What are the possible values for k? So I said before, one solution means this is a perfect square. That's the only way there can be one solution if the quadratic expression is a perfect square. So that means I want to write it like this. So I need to find something I can put it in the box here so that this is a perfect square. So the number that has to go here, when I square it, I need to get 100. The number that goes in here will just be the square root of 100. Now, the square root of 100 is 10 or minus 10. If I square 10, I get 100. If I square minus 10, I get 100. So this expression could be x plus 10 all squared. When you expand that using FOIL, you get x squared plus 20x plus 100. Or it could be x minus 10 squared. And when you expand that using FOIL, you get x squared minus 20x plus 100. So this will be a perfect square. If k is equal to 20, then it will be x plus 10 squared. Or if k is minus 20, and it's equal to that squared. So if this were to equal 0, the only solution is x is minus 10. And if this were equal to 0, the only solution is x is plus 10. If x minus 10 squared equals 0, x equals 10 is the only solution. All right, sorry the video did go longer than I expected. Best of luck studying. First 5 people to reference this video, you can have a caramello koala. You're a superstar. Have a great day. This has been the luckiest maths teacher in the world.